everybody to coming to this month's Launch and Learn, my series, the geospatial industry and coming from different avenues. Today, my friend and colleague, Mark McGuire from HRG, has graciously accepted my invite to speak today. Mark is a practice area leader in GIS and asset management at Herbert, Rutland, and Grubik. I hope I said that right, Mark.
Yeah.
He will discuss the emerging trends in GIS, asset management, and AI for location intelligence, with a particular focus on one of the biggest challenges our region faces, aging utility infrastructures. I know we've all dealt with that.
Yep.
He's also going to share some thoughts on the skills needed for up-and-coming GIS data scientists. I love that term, Mark. We're not just, we're scientists now.
We should be.
And to take advantages of these concepts in the industry. Short personal aside, I've known Mark since my Orange County days, I believe. So we're talking 7-8 years now, Northwest PA. Mark has been a great bastion of information. With him being on the private side of things, it's been real interesting talking with him over the years, and how the private side and the public sector can interact together. I do believe he does a lot of work for public sector in his. So anybody here that has questions on either side of the aisle, Mark's your man. He's been around it all. And with that, I would like to turn it over to Mark McGuire.
All right. Thanks, Joe. I appreciate it. I already see some names on the call here who I know are smarter than I am, so feel free to ask questions along the way. And this is kind of a new presentation for me. I haven't done this one in a while, or something like this for a while, so it's going to be kind of high level and a little bit cynical. Not too cynical, but a little bit. We're talking about all this stuff. This is sort of my perception of how things are going when it comes to like AI and all this talk, all these words that we're hearing these days about, deep learning and IoT and all this stuff, digital twins, how it kind of can relate to really what we do as GIS professionals, both in the private sector, which is where I work, but also the public sector, which I know is a lot of where you work. But, and I say this at the very end here, like, we don't get caught up in the jargon of things, these fancy new words, because we're doing all this, and we have been, I think, as a GIS practice for decades. But our tools have been getting so much better, our technology and all that. So, obviously it's things that we should capture. Now, a lot of these examples are, I can honestly say we as HRG aren't doing some of this. This is just things that I've seen in industry, and I know other firms are doing it, but I just wanted to kind of just give an overview of, like I said, things that I'm seeing in the industry and how it relates to the work that we all do, especially here in Western PA and Ohio, Eastern Ohio and beyond. So yeah, with that, I've pirated some slides from different areas. So like my colleagues on the call here will roll their eyes at some of these because they've seen them all before. But we all know that GIS has changed, right? From what it used to be when I started many years ago. So, when I talk to people about GIS, I like to throw out this slide. There's Jack Dangermond looking very young on the bottom there. But the core concepts are the same, right? How we use GIS for analysis. That old ArcSDE diagram is still actually, maybe take out ArcIMS. Well, ArcInfo too, I guess, but the whole DBMS and ArcSDE SQL Server is still the important concepts of what we do, and I'll talk about that a lot. Enterprise data management is still, I think, the biggest thing we can contribute to when it comes to a lot of these other terms that we're going to talk about today. Feel free to ask questions along the way or correct me when I make a false statement. We all know that GIS has really evolved to this, right? Not just mapping, but data analysis and apps. And I think everybody on the call really knows this. I'm stealing a lot of slides from, or a lot of images from Esri. I try and source them, but we're a partner with them and we pay them a lot of money as well as our clients. So I'm just using all their stuff. But, you know, when we talk about next gen big data, as I like to call it, you know, there's lots of different components here, right? From the scanning technology, traditional robot scanning, to these, like that on the lower left here, GeoSlam, which is it's basically a walking LiDAR type data collector. You know, digital twins. Drones are a thing of the past now. I mean, not a thing of the past, but drones are, everybody's got a drone these days, right? But there's LiDAR drones, there's drones with gas detectors and leak detection and all that stuff. Obviously, scanning is huge. The products from scanning, and then building information management systems. This is a bridge from Trimble that they're modeling in 3D. Also, we've been playing with this as a company a little bit. Trimble Site Scan, which I'll show you, is I'd be curious if anybody else is working with that. But you know, all these fancy graphics and things that we get thrown at us from all over. You know, how do we play a role in this, right? When it comes to GIS, and like I just said, I think the biggest thing is data management, right? You can have all this data, you can have it in different places, you can do a really cool scan of a building. How do we actually manage all that in one place? And like Joe said, I'm focused on infrastructure, and the folks on the call, Russell and Andrew, are sick of me showing pictures of stormwater inlets, which I'm going to show them one in a second. But when it comes to what we care about here, it's infrastructure, it's pipes and water, wastewater, and that's what we do as a company. A lot of what we do. But you know, this civil infrastructure management has evolved, and I stole this slide from Trimble. We're partnering with them on CityWorks and some other initiatives as well. So this is kind of a CityWorks related slide, but I think it sums up the power of what we can do, what GIS can do, especially when it's coupled with a CityWorks or a MuniGov or one of these other Cartograph or one of those applications as well for enterprise asset management. I mean, we've come a long way. Still, organizations are still using paper in many ways, right? So I think before we can get to a lot of this stuff, we still got to start here, right? And manage the data efficiently as we go. You know, thankfully, most of us are probably at this GIS geodata stage, but when it comes to the right-hand side, this is what we're talking about, you know, optimizing work activities, doing predictive analysis of failure. Again, I gonna keep coming back to stormwater pipes and sanitary pipes, but it's the same with roads and even buildings, any sort of infrastructure that we're dealing with, especially out this way. You know, that's where we got to be. As I think as a practice, we have to keep moving to this direction. And I think we need to be there before we start integrating a lot of this. And then a lot, you know, if we're not there, a lot of this stuff is sort of a one-off type service, right? The point is integrating, and I'm not saying that we've done this already. We're still many years from doing this, but it's just kind of changing people's thinking, right? To understand all of this. You know, while infrastructure management is evolving, our assets are not. You know, this is something we've been playing with in our office. This is it's a 3D camera that can actually fit between storm grates, so you can do a condition assessment without actually having to open up a grate. But you know, the amount of data that we can collect now without doing a ton of manual effort. And you can see this is the ultimate failing inlet box, right? With ponded water and vegetation and collapsing bricks. I mean, this is what we see a lot. But there's different tools that can make us collect that more efficiently, and think about just how much information we're getting from just one click of the button. Whereas even a year ago, we did a whole survey out in Harrisburg where we had to open up, I think, 3,000 stormwater grates to get this sort of information. So I've shown this slide a couple times. When we are talking about asset management, this was from a really good presentation at a Trimble conference. He's actually a professor of asset management in Canada, but at first I was offended by this. I'm like, no, GIS is asset management, right? They're the same thing. You need GIS to do asset management, but he's right saying that it's a number of different things, right? It's not just one thing. It's not just a GIS. It's not just BIM, work orders like CityWorks, like OpenGov. Those are software that plays with asset management, right? And then IoT, the Internet of Things, which I'll mention a few times here. We have to think broadly when it comes to all this stuff. But I will say GIS maybe plays the most important role in asset management, at least in my book. So, okay, so now I'm going to just go through some of the terms that we're hearing a lot, and maybe I'm going to push back on some of them. And like I said, maybe be a little bit cynical, but we think about image classification and pattern recognition, right? That's a big thing now. We can do it a lot more quickly. We can do it more efficiently, but that's been around for a long time. Hence my like Windows 2000 maybe screenshot here doing, I can't see anybody, but virtual show of hands about like people who have done this before back in the day, doing image classification, you pick your training samples, you can do supervised versus unsupervised. There's object-based versus pixel-based. That sometimes is advertised as a new thing, but that's actually been ingrained in ArcMap for a while now. So that's object-based is when you're doing image classification, you're looking at not just the pixel itself, but the neighboring pixels. But anyway, we do this a lot in different ways, and you apply these algorithms, right? You can do statistics and nearest neighbor, and all of us probably GIS 101, we were taught various parts of this. It's been around. It's being touted as kind of a new thing sometimes, but it's been around. I'll just say that. And I mentioned neural networks too. So this is a throwback from me, and my colleagues maybe on the phone will get a kick out of this, or I did. I did a master's thesis way back in 2003. I used neural networks. So neural networks are it's a statistical tool that's supposed to mimic the way that like biological systems respond and activate. It's a form of artificial intelligence. My advisor way back was using this to do like remote sensing, and I was doing some environmental data collection, and she said you should use neural networks. I'm like, I don't know what this is. And it's meant for big pieces of data, right? That's so big that it's hard to detect patterns from traditional methods. But I had a sample size of like 40 or 60. She said, no, I'll do a neural network. So I did. Anyway, I dug this up from the grave here, showing you that, some of these concepts have been around for a while. The computing power and everything else is greater than it's ever been. But, these sort of classification, pattern recognition have been around for a while. And I'm going to botch most of this, but these terms, deep learning is the new one, and you'll see that in ArcGIS Pro. They all relate to this machine learning and artificial intelligence. I did steal this slide from a presentation where machine learning has been around for a while, like this image classification, segmentation, clustering. That's what we do to detect patterns in GIS. Imperial Bayesian kriging. I do remember kriging back in the day too. All machine learning, so you train your models. But then from there we go to deep learning, and deep learning is deeper, I guess. But there's differences there for sure. But long story short, there's a lot of tools in ArcGIS Pro that can do this more efficiently, and they're available now per everything when it comes to GIS and Esri products. You got to make sure that you have the right extension. I think some of these require image analyst and 3D, but there are Python libraries you can use. Essentially, you're just training your data sets, right? Which is essentially what we did with image classification, right? When you do supervised training and you pick training sites, and that's still happening, but I think we can, with all the data sets we have now, 3D point clouds, there's a lot more tools to do this on a much bigger scale for sure. But again, these are my observations, and I can't say I'm using any of this. I don't know if anybody is on the call. I'd be curious if there are, but this stuff's out there. It's out. It's always been out there, but it's maybe a little bit better now. I did this actually a few years ago with some data I was looking at to see if we could do well, there was some multispectral data that was looking at different types of land cover, land surface, and seeing if we could actually detect like concrete slabs based on, and this is just based on, I think, either object pixel detection, but this was through a third-party vendor. And I was playing with the different confidence levels in the pixels, and you can see here it did okay, but not great. Because you'll see, I think in the next slide here, yeah, one of the things that we do a lot back to infrastructure is stormwater authority development. So stormwater authority is usually based on a fee structure that is based on impervious area for different properties, right? So we in GIS will come up with impervious area, square footage of IA. But you can see here, based on this, we didn't do so great because we're not really capturing all of the concrete slab. Now, you can mess with this with different confidence levels, but this is some of the pattern recognition that we were trying a few years ago. It's important, like I said, for stormwater authority development. This data set was done the old-fashioned way using stereoscopic photograph. I'll stop with the big words, but basically hand digitizing using multi-angle imagery that was collected, because we really needed those sharp edges to be collected, right? If there's vegetation or other obstructions, we weren't getting a clear picture here. So we've got some work to do there, but Nearmap is a company. I'm sure a lot of you have been exposed to Nearmap products. They have a lot of AI tools that they're using now, which are all pretty cool, I have to admit. I've just worked with some of their imagery before. We're not like a Nearmap partner or anything, but some of the detection that they can do on their imagery. And if you're in an urban area, they'll fly the imagery 2 or 3 times a year. So you can really start to look at change detection. I was looking at a product they have for concrete and pavement health, like looking at cracking and spalling in concrete. Here, this was just snapped from their website, looking at damage assessment after an event, a hurricane or bad weather event. They can also do feature extraction they can actually detect manholes and storm inlet grates as well. So they seem to be doing some really cool stuff. And I know there's others out there as well, doing a lot of this AI image detection. I know Woolpert engineers too. They've got some cool algorithms that they've been using for a while now for some of this stuff. Back in the day, we used to use some of this for more global change detection, using satellite imagery and Landsat and all that stuff decades ago. But this is pretty amazing that we can do this feature extraction and then look at multi-year information. And that's all powerful in our GIS systems, right? If we can extract this data, we can then do our analyses that we usually do in ArcGIS Pro. So we all know scanning is a big deal, right? Terrestrial scanning, using different types of scanners. I showed you that one, the GeoSLAM, that you just walk around to collect point cloud 3D data. ArcGIS Pro has a lot more tools for 3D scene work than ArcMap ever did. I think it works a little bit better. I've played with it just a little bit, but I still think the industry is using Pix4D and Trimble Business Center to really do the processing and create those models. That's a TBC screenshot to the right there. And for the actual BIM work, if you're actually, and I will botch this talking about BIM because I don't really work in that space, but Revit and other systems like that are really the powerhouse for managing all this data. ArcGIS Pro, as says they can do a lot in there, but I think we're really looking at more visualization and creating your DEMs, looking at your point cloud, doing some modeling, maybe some flood modeling. I know that's a new add-on to ArcGIS Pro, but we're still, I think these other software tools are still are really the powerhouse, like I said, with actually developing the point cloud, correcting it, taking out your vegetation, that sort of thing. But what I keep coming back to, though, is how are we managing all this long term, right? As opposed to just a bunch of one-off projects. Hey, we're going to scan this building. Here's a 3D image or a 3D model. You're good to go. That's what, like I said, it's not like we're doing this all now, but it's something I think we need to really look at. How do we manage all this stuff once we get it in one place? And I know some of, like Penn State and some of the more progressive schools like that are actually using a campus-wide BIM to manage 3D data, but most of us, probably like consultants and other agencies like yourselves, are still managing like kind of one-off data sets. ArcGIS Indoors, I have not worked with. I always see the same few case studies out there on the Esri side, so I don't think a lot of people have really adopted it at this point, but that's where we need to go, right? Because then we can start to combine our different data sets and actually build intelligent, not just views like this, but actually databases that hold all this information. And I think it's essential when it comes to lifecycle asset management. I'm going to show up another slide in a couple here showing 3D asset management. There's a product called GeoBIM as well, which I'm not as familiar with, but I think it's an interface between BIM and GIS. That's another tool for that. But I think as an industry, we probably have a long way to go here, but just kind of what I'm seeing in terms of the importance of how we integrate a lot of this point cloud data to actually do asset management. I think this is sort of where we need to be. Digital twins is another term we hear all over the place, which I always push back on and say, hey, we've been doing digital twins in GIS forever, right? I mean, it's simply a digital twin is a digital representation of something on the ground. Usually it's referred to more in the 3D space, but it could be anything, right? Any assets that we're mapping, you could call, it's a representation of reality for sure. Obviously, our models are becoming more complex and, we're including more in that. But this graphic on the ArcGIS digital twin thing is really everything we're already doing, right? A lot of this, but it's good to coin the term and think about it a little bit more in depth. And, when we're creating our data, we are creating a representation of what's out there, right? And the more information we can feed into that, the better, right? Whether it's 3D data or some live streaming data, whatever we can do makes it that more powerful. Water, wastewater space, they've been doing that for a long time. This is a really crappy picture of an actual PLL module for a treatment plant, which is a schematic, but there's a lot of data in here, right? And that's a whole other world of engineering and data science when it comes to water, wastewater, and flows, and PLL controls, and all these terms. But it's important because when we're doing our mapping work, some of this data can come in really handy, especially when we're talking asset management, right? Getting different sets of data, being able to pull out some of this data and actually work it within your GIS. This is more typical, maybe digital twin that we see. This is a point cloud. It's a colorized point cloud turned into an actual 3D model. This is a digester, I think, at a water wastewater plant, but they can take this, they're going to design some upgrades to this facility. It has a really cool staircase that was rendered almost well. You just have to take a little leap, maybe, if you're coming down the top here. But, this was just generated using 3D scanning. And then you could, especially now, once it's in this format, and I think it just went through Trimble Business Center and maybe a third-party software to do that. But once it's simplified, it's certainly something you can work in ArcGIS Pro. And I keep coming back to this because that's kind of the theme here. Why it's important to think about vertical assets, digital twins, and GIS. Because, there's important data here that we want to capture, right? I just made this up, but this valve here was replaced 12 times, right? So that's something we want to know. It's great to have a 3D model, but what are the attributes associated with that, right? Because we want to know for lifecycle management whether or not that valve really does need to be replaced. What are the equipment around it that might need to be replaced? Or if it's damaged, is it going to lead to other equipment being damaged, et cetera? So, it's this concept of data management, lifecycle analysis. This is a screenshot from Trimble CityWorks, but shows the importance of asset management, but not just your horizontal assets, but your vertical assets, right? GIS, we might just have one point which has where this tank is, but if you get into more this life cycle analysis, there's actually a whole hierarchy of other assets under this tank, right? It could be a tank. Underneath that, you might have 8 control assets. You can tell I'm not a wastewater engineer, but, and then you open that tree and there's 8 more components. And then within that, there's 4 more components, and you get down to a washer or a nut. That could be that whole hierarchy that's all being contained in that one point in GIS, but it's all these related assets. So again, some of these softwares can be fairly complicated when it comes down to it, but it's important to think about all this in a 3D perspective, and also an asset lifecycle perspective too. Talked about the IoT. That's pretty much, there's data everywhere being captured all the time. The stuff we think about in like environmental areas, like water quality meters, flow meters, air quality meters, but then there's CCTV videos, there's emergency receptors, there's all sorts of things out there. And this I'm just talking from not experience. I've had a little experience with Geo Event Server, but there are GIS tools that specifically can bring in this sort of technology. ArcGIS Velocity is pretty pricey, and you have to have a lot of hardware to support that. Geo Event Server has been around for a while for like real-time data collection, but these can't all be worked into the GIS environment. I think you'll see more often, and it's something that I think we're going to be doing for a water wastewater client here soon, taking data from a SCADA system, taking an export, running some Python on it to format it for import into another system that might end up in the GIS or as part of a asset management software. That's probably more of a common practice, is to work some magic with Python and FTP to work data in different directions. But some more sophisticated software, even in the ArcGIS Esri environment, do exist for that. I mentioned at the start the site vision. As a company, we've had some demos. We're looking at it for mostly construction projects, pump station projects, and Trimble is really pushing this now. It's basically a augmented reality system where you can see your proposed plans through a tablet. I think my colleague Christine just did a demo with PennDOT or something, but this has been out for a while, and how does this work back into GIS? Maybe I'm not, a couple different ways, I guess, but the GIS probably is the one creating a lot of this data to start. But I think this is more of a visualization tool when you're on the site. But clearly it's part of this discussion of some of these cooler tools. AR, VR, I've seen it work with GIS, but I don't see a ton of applications, I guess. It's always one of those things, when we're talking with clients or colleagues looking at potential projects. I feel like AR, VR is kind of one of those things like, oh, that'd be really cool if we could do that, but we don't really need to do that. It's that need to have, nice to have versus the cost. But there's Sewer AI is a new, they've been around a while, but they have some new algorithms where they can actually do detection. This was playing some really corny music earlier, so if it's loud, I gotta stop it, but yep, I can shut it down. There we go. Good. This is just straight from their website, but we deal in pipe videos and cameras all the time, but there's some new algorithms that'll actually pick up. Usually our staff will just watch videos, right? And they're kind of horrifying, like Nightmare on Elm Street, I think. But you never know what you're going to see around the corner. But these tools can actually detect features, mark them, and I think with some pretty good confidence ratings. Now there's the obvious issues, but it can detect a lot of more subtle inundations in the pipes and that sort of thing. The results I heard can be mixed depending on the environment, but these type of systems are self-learning, so they're going to get better and better as we go. I know our staff spends a lot of time looking at pipes videos, and if we can speed that up and use AI detection to not just show where the pipe is, but try this again. There we go. We're used to seeing these kind of reports when things are run down pipes, but to actually put points where some of those defects are, which I know there's a Hughes is a company that GraniteNet is one of their software that we've worked with a little bit, but apparently the data will go back and you can run an SDK that pulls it out and actually puts points along the pipe where those actual, right here you say, all right, there's a problem 200 feet out, but it'll actually detect those and drop them into your GIS. So you can not just see where the pipes are bad, you can actually, like the whole segment, you can actually see the detail to where those pipes are failing. So and lastly here too, utility data sets are big. I presented on this utility project at PAGIS, and we're just collecting a lot of data, right? And the GIS is the best way to collect that, right, and to manage it. I know I've said that enough times already today, but they can be even bigger too when we're talking utility survey. If we are trying to work in the 2D with the 3D, we're doing this big campus survey, and there's a lot of value in the 2D to knowing where all your pipes are at, but then there's even more value in the 3D. And we're doing this in subsets. We're scanning, we're doing subsurface utility, but they're not really coming together. And I think some of the tools that I already told you about would be really valuable here as we go forward. All right, just wrapping up here. I mentioned the tools in Pro. I think for analysts, especially younger folks that you might be working with who are kind of overwhelmed maybe at some of this, we get training in school, and it's ArcMap and ArcPro, and here Esri gives you these global, let's look at forest fires in Western United States and go. And then we hear about all this other stuff. We're overwhelmed, but there are a lot more tools in Pro than there ever were before. These deep learning libraries that I mentioned, the utility network architecture, that's a whole other thing. I don't do utility networks, but a lot of other engineering firms do for bigger clients. There's all this architecture involved with that for modeling. And then the point cloud, I say point cloud visualization and 3D scenes in ArcPro. That'll sort of get you started for sure. I think for younger folks too, and I see this a lot at our company too, like young folks coming in and saying, hey, I know GIS and I know how to use ArcGIS Online, and but then the data is ended up all over the place or stored in awful weird places. Database management is still an really important thing to learn, and that is going to be so much more important with all this other data that's coming out, right? Kind of SQL 101, relational database science, as I call it, is still really, really important. Knowing how to store data with related tables, and then all the other parts that go with that, the validation types, roles, they all apply, especially when we're talking 3D object data in CityWorks or all these other software. It's all still very, very important. Scripting, automation, programming, it's all important. And it's in the GIS space, but also in the water wastewater space. It's the people who do that programming, PLL module programming, that are able to take data from one place, put it into another place. Python is still, I think it's even more, I'm not a programmer, but it seems to be more universal than ever outside of GIS, like in these water wastewater modules, any sort of automation systems. It's still a great thing to learn, to get involved in all of this different data management work. Coursework, think outside of the box. This is my stupid GIS joke, not think outside of the box, but the ellipsoid. I have a colleague of mine, he's actually an engineer without GIS experience, but he's taking this data science for smart cities at Purdue, which looks really fascinating. And that's a whole other practice, this data science, analytics, but it all ties into GIS. And I think for younger folks or folks who want to polish up their skills, that would be something great to bring to the GIS environment. Smart cities is another one of the terms. I didn't even mention that, but that's another new term. Cities have always been smart in different ways, right? But now we have a term, and it's supposed to bring everything together into one, which is possible, but challenging, like for all the reasons we've been talking about. So really quickly, these concepts, like I said, have been around for a long time. So I just encourage folks not to get overwhelmed when they see these things, it's like, oh, I can't do that, or this, I need a PhD to do this. No, it's so much of it has already been built into the tools we've been taught. I keep focusing on infrastructure management. I just think it's the most important thing out there. I'm biased because that's what we do, but all these tools can really help, not just show where our stuff is failing, but provide ways to improve it and predict when things might go wrong in the future. Esri and Trimble, I mentioned a lot about, but there's other things out there as well for integrations. It's not just everything Esri or everything Trimble. So make sure you think about those things. And then, like Joe said, data scientist, kind of a cool word, but these are the things I think people should think about. The role is not just mapping, but asset management, smart data integration, and then really thinking 3D, 4D, 5. I don't know. There could be an 8D in 2 years, but like I said, don't get lost and continue to do what we all do in GIS. So that is all I had, Joe. It was very long-winded, but happy to take feedback or questions or insults or whatever the group might have.
I'm sure the insults will be coming, but thank you,
Okay,
Mark.
good. Standard.
Great presentation. While people decide if they're going, whatever questions they would like to ask, you feel free to chat or jump on. I'll make a couple observations. To your point about the digital twin and the AI, I've always thought that we've been doing that forever. I don't know that I ever, the classification, that was one of the first things I learned that was really cool in the GIS sphere back in early 2000s. And all that is a data model.
Mm-hmm.
And that's all these AI and these chatbots are just data models that have been programmed. And that's what we were doing essentially way back when, was programming it to see this and return this. And then over time, it just got better at it. So you were right in saying, the recent years, don't get caught up on the terms, the AI, the digital twin. We've been doing that forever.
Yep.
Well, since Drew decided to leave us, I'm sure for those of you that don't know Drew Fiorinelli, he has left Esri. He has taken on a new role. So our new rep, we got to redo some things, I guess, but we're looking into the ArcGIS indoors. Cool. Central Valley region here, a bunch of counties, basically a pilot project on that. So does one other thing I didn't want to point out, the CCTV thing, Esri actually has a solution for the cameras, the CCTV solution, where you can pull that stuff right from the Q's Granite Net. I was doing this there at Hampton, where you could pull that right from all the stuff that you capture, and then it translates it into vector points right in your map. And then you can color code it based on what the defect was. Cool. There was a bit of coding with that. Gateway set that up. Don't hurt me for saying competitors' names.
That's all good.
But there are a lot of solutions for that. So are there any questions? Anybody? Please jump on or type it and I'll read it out to Mark if you can't see the chat. Todd says Autodesk has Info360 Asset Cloud Platform that imports CCTV inspection data and media, maps out defects, points, etc. with ratings. Useful for risk and prioritization analysis. Quite a number of solutions available for CCTV. Yeah, there are a lot.
Yep. So I found too, a lot of the folks we work with got those programs set up many years ago and kind of been working a little clunky, but then they, the software upgrades to like cloud-based and enterprise, but to get there, it's an extra cost. And then it's like, well, we're backing those up and we're putting them on the server manually every night. It's working fine. So But yeah, I appreciate that, Todd. I mean, there's a lot of changes and a lot of better ways we can all be doing stuff, but it's kind of changing the process, which can be tough, you know.
And changing the process, that's one of the biggest things that I've learned. Like, you have digitization, which is the converting our paper products to digital products to be used, georeferencing, whatever. But then the other biggest thing is the digitalization. And that is the turning these paper processes into digital processes. So instead of submitting a paper form, we're just filling stuff out online and everything gets run in the background instead of a paper form that goes from here to here to here, or a digital form that gets, placed here to here, and automating a lot of those processes. And Python has become very, very ubiquitous in that realm.
Yep.
Anybody else? We got a lot of people here. Come on, folks. Ask Mark a question. Anything. So while we're waiting, if anybody asks, we still have a few minutes. Mark, what's your thought? The role of GIT in general, the technology, how do you see it playing out? What is your assessment of, are we going to use it more? Is it going to become very ubiquitous across all landscapes? Is it still going to stay very niche? Or how do you see our industry evolving from your perspective?
Ooh, that's a tough one. Well,
I got to ask this in an interview, so that's why I'm throwing it to you.
Oh yeah. Yikes.
Yeah.
I wouldn't do very well in that interview, but I think it's, and I hate sometimes I feel like I knock Esri too much, but obviously my whole career is based on them, so I have lots of things to be thankful about when it comes to Esri, but they certainly have had a monopoly on the mapping products, and we still haven't seen other, say, competitors on the mapping side come in. However, I do see all this big data stuff to be a little more, the market's going to be diluted for tools that you can do all this analysis, like, and I think we are seeing a lot of other visualization tools that aren't Esri, like, using some of the different base maps that are out there, Tableau and some of these just data engines, data mining. I do think Esri isn't going to be the only solution to do all this analysis. It's going to be one of many. And I don't think that back in the day it was Esri or bust, and that's not knocking Esri. I mean, it's just the world of data and big data has just exploded so much in the last decade. There's a lot of competing tools out there, and that's why I said in that one slide, like, learn some other tools and other practice areas that can then feed into GIS. I think that's going to be critical. Somewhere in there was an answer to your question, but I don't know. It's evolving. It's always going to be evolving.
My thought is that GIT is much similar to the realm of geography as a whole. And what I mean by that is, I think it was Tomlinson that said everything happens somewhere, therefore it can be mapped.
Mm-hmm.
But geography is at the root of everything. You don't have any other subject without geography. You can't have math, science, because the geography, the location of that person that, Euclidean geometry, where was Euclid when he developed that? What were the geographical influences that may have contributed, or the temporal contributions to his discovery of Euclidean geometry, just to throw or Pythagoras. We all know the Pythagorean theorem. Where was he when he developed that? So to modernize that approach, GIT, to me, IT, the information superhighway, everything that we, right here, we're on the computers. the GIT is going to become universal, and a lot of industries are realizing, yeah, we've had all these databases, but we've been missing one thing, that location component. And now they're realizing and scrambling how much value there is in the actual location part of it.
Yep.
And that's where we as geographical data scientists, they're scrambling to scoop us up at low cost, because the world at large is finally catching on to what we do. In my opinion, from what I've seen, with like my job search earlier this year, they do not understand that the world at large. I mean, our industry is having a identity crisis at times. Are we GIS? Are we IT? Are we this? Are we that? Where do we fit in? But I think we fit in everywhere.
Yep.
And that's where we need to really dive into how can we exploit the spatiality of what we do. If that makes sense. It makes sense in my mind.
No, it does. I hear you.
Does anybody else have any comments, questions, queries, concerns, insults for Mark? No? Well then, Mark, I guess you gave such a powerful presentation. They were either intimidated or you answered all the questions.
Or they all fell asleep. It's either or.
That's a possibility too.
Yeah, it is. No, it's all good.
That was a very informative presentation. I want to thank you very much for taking the time out of your day to do this for us. If anybody has any other questions for Mark, if Mark, you just want to throw your email address in the chat real quick.
Yep.
Somebody may want to reach out to you for a copy of your slide deck or something. I just want to make sure they can get to you. There we go. Yep. So if you would like to reach out to Mark, please feel free to email him. And I encourage you to name call him in your email as well.
Yes, please.